Video, we will be going over data masking and disaster recovery. Data masking is the process of creating duplicate data that is structurally similar to the original by changing the values and keeping the format constant. In other words, it encrypts personal identifiable information such as names, emails, phone numbers, etc. This maintains data integrity by keeping important information private. So why do we need data masking? Well, with data masking, software testers and third agent parties can share data without exposing confidential information. I also want to take a moment to better clarify and distinguish the differences between data masking and access control, and how data masking is separate from encryption. Access control focuses on ensuring that only authorized users can view or change sensitive data. While access control can protect sensitive data in production environments, the same cannot be said in non production environments. As for encryption, encryption is capable of concealing sensitive data as well as decrypting it based on encryption keys. Data masking, on the other hand, aims to conceal private data, but there is not a way to demask it. Additionally, encryption focuses on protecting data from external malicious attackers, whereas data masking is for protecting against internal users such as unauthorized users. There are two types of data masking: static data masking and dynamic data masking. Static data masking provides realistic data for development and testing of applications without disclosing sensitive information. The live production database is duplicated, and an offline copy, known as the golden mask copy, is constructed with all the sensitive fields masked. Static data masking occurs at the column level. Users select which columns they wish to mask, and for each column selected, a masking function of their choice is applied to those columns. There are several masking functions to choose from, which we will discuss later in this video. Depending on the masking function, the pre-masking data and the post-masking data can be highly related or not related to the original database at all. For example, in the image below, we have the original database shown on the left and the golden mask copy on the right side. We see the name John Elliott in the original database is replaced by another name, Paul Taylor, in the golden mask copy. The advantages of static data masking is that sensitive data is permanently removed outside the production stage. So, if an attacker attempts to change a statically masked database, the sensitive data is not in any risk. However, there are some disadvantages with static data masking. This type of data masking cannot be used to protect the original database since the data is permanently replaced outside the production stage. If static data masking returns an error, all masking operations are suspended. Consequently, the copy of the database is not deleted and may contain sensitive information. Another big disadvantage is that the two databases are ordinarily not synchronized. The masking process is not done in real time, so it may take minutes to hours to complete the masking process depending on the size of the data. The golden mask copy commonly lags behind the live production database, but it can be updated on a periodic basis. Dynamic data masking, unlike static data masking, is real-time data masking. Dynamic data masking aims to limit exposure of sensitive data, preventing users who should not have access to the data from viewing it. In other words, it conceals the data so that the requester does not gain access to confidential data, as well as ensure that no physical changes are done to the original production data. This way, the sensitive information never leaves the live production database. Here, the customer decides how much of the sensitive data is to be revealed. However, unlike static data masking, the data here does not look realistic. Typically, all if not a certain range of the characters in the original database are replaced by a constant character. As you can see in the image below, all but the last four characters of the Social Security numbers are replaced with the character X rather than other random numbers. The advantages of using dynamic data masking is that the third agent parties are able to access information quickly. With simple data masking functions, it is possible to retrieve a masked copy of the data in real time. However, update functions are not compatible with dynamic data masking since writing over can corrupt the original database. As mentioned before, there are several data masking functions or techniques that can be applied. For the purpose of this video, we will be reviewing three techniques: substitution, data redaction, and encryption. However, you can find more data masking functions in the link provided. First, we will talk about substitution. We saw this technique when talking about static data masking. Substitution replaces existing data with random values from a pre-prepared data set that looks similar but completely different to the real data. This technique is very effective in terms of preserving the look and feel of the existing data while also maintaining the integrity of the original data. Next, we will talk about the data redaction. Data redaction blocks out sensitive or confidential data. We saw this when talking about dynamic data masking. The process of redaction occurs when it's being retrieved from a database and it leaves the data in the database unchanged for authorized access, but for the people accessing the sensitive data who are not authorized to see it, data redaction blocks it out. There is full masking, which completely blocks out the data, and partial masking that only reveals parts of the original data. Looking at the example in the image below is an example of partial masking. While if it was full masking, all the numbers of a Social Security number would be replaced by the character X. It's dynamic because the process occurs as the data request occurs, and it returns the requested data with the personal information concealed. While data redaction alters the data, it nonetheless loses the data's integrity, and this ultimately prevents testers from verifying application logic. Next, we will talk about encryption. Encryption is known to be one of the more popular and secure types of data masking. This technique implements an algorithm to mix up the data. This typically does not leave the data looking realistic as shown in the image below, and can sometimes even make the data larger. Unlike other data masking functions, encryption can destroy the formatting and eliminate the look and feel of the data. Encrypted data rarely looks meaningful. While the data is encrypted, authorized users can only access it with an encryption key. Now we will be talking about disaster recovery. In today's world, a cyber threat or natural disaster is not a matter of if, but when. This is where disaster recovery comes into play. So what is disaster recovery? It is a service for businesses and organizations to recover data as well as to ensure that their infrastructure and systems are intact in case of events such as cyber attacks or unexpected system shutdowns. Disaster recovery is not the same as a backup plan. Backup can be more understood as an archive of data whereas disaster recovery not only keeps copy of data files, but also replicates the servers and updates them. Backup is not ideal to provide the continuous synchronization and fast recovery demanded by today's modern world. In contrast, an effective disaster recovery is the continuous replication of business data to a separate location where it can be protected from an attack and from where it can be restored quickly to maintain business continuity. This is a disaster recovery solution provided by IBM Cloud Management Service, known as CMS. This image illustrates how disaster recovery is implemented in a cloud-hosted enterprise applications. We are going to consider the primary fault domain on the left side as the cloud site that needs or is going to be backed up through the disaster recovery plan. The middle section represents a disaster recovery site or engine. And on the far right side is the replicated or the target system application cloud site. As you can see, there are 5 key elements in the disaster recovery engine. The discovery and plan, control and automation, management, replication, and networking, all of which plays a certain role in replicating the infrastructure. For the sake of this video, we are going to be discussing discovery and plan, management, and replication. The discovery and plan component collects and extracts information and characteristics of the primary cloud's infrastructure and services. The management component recovers system management capabilities of the primary cloud site, such as configuration services at the disaster recovery site. The replication component replicates data from the primary cloud site to the target disaster recovery site so that it can continue operating on the disaster recovery site even if an outage brings down the primary site. To conclude, data masking and disaster recovery are a few of many security countermeasures a business or a user using a cloud management can implement in order to protect information stored. Data masking aims to protect confidential and sensitive production data. By concealing, fully or partially, such sensitive information, non-production users such as software testers and even outside organizations like customer service or a medical center can access the database without risking too much exposure. How much of the data is revealed to the third agent party depends on what permission they have. There are 2 types of data masking: static data masking and dynamic data masking. Static data masking provides realistic altered data that is saved in the golden mask copy. The duplicate is made during the production with altered data and is sent back to the requester. Dynamic data masking blocks the requested production data and is done in real time. The requester decides what masking functions to implement of the production database. There are a number of masking techniques, but we looked at substitution, data redaction, and encryption. Substitution maintains the production data's integrity in that the users can verify or validate information from the original database. However, with data redaction, a user is not able to verify or validate information since it is blacked out. Encryption best secures the production data because it requires an encryption key. Disaster recovery protects and recovers a cloud's data and its infrastructure, as we see in the IBM's CMS platform. Thank you for watching this video.